Our squad of Ultimaker 3D printers are the workhorses of the ANU MakerSpace. They are standard FDM 3D printers. This means they work like hot glue guns. They melt plastic and then squirt it out the nozzle. These printers are cost-effective making tools. They are green tools and easy and safe for anyone to learn. You don't need any prior knowledge, and the software is no more complex than sending a file to a paper printer. You can create models in software such as Fusion 360 or SketchUp, or simply download a ready-to-print file from an online library such as Thingiverse. Later on, if you're feeling ambitious, you can even scan physical objects to create a 3D model. However, to make a simple relief printing plate, I'm going to show you a trick using only Cura, the slicing software used to communicate with the printers, and its inbuilt Lithophane setting. This is a lithophane. While it doesn't look like much in the shade, when you hold it up to the light, the shadows of the different layers reveal a picture. To make this, Cura determines the height across the object based on the dark or lightness of the image. While the different layer heights could lead to some fun experimental rubbings or embossings, to use this function to make a simple printing plate, do the same process but with a black and white image. To prepare your file, create a black and white image and save your image as a JPEG. As with all things printing, remember to flip your image beforehand. You can bring in your black and white image and do this whole process on the computers in the MakerSpace. Or you can download Cura for free from the Ultimaker website. In Cura, you'll see a layout of a printer bed. Change the settings to match the printer you want to use. Most of the printers in the MakerSpace at Physics are Ultimaker 2 Pluses, but you'll need to check which printer is free. Select the filament type. We use generic PLA and our standard nozzle is 0.4mm. Once Cura is ready, drag your black and white image into Cura. Specify your preferences in the pop-up menu. The first setting is the height. This is how tall the raised areas, the ones that will take ink, will be printed, not including the base height. I recommend a height of 1mm. The second setting is the base height. This is how thick the base of your plate will be. I recommend a minimum of 0.5mm for a flexible card-like thickness, but you can raise this if you want to create a more rigid printing block. The size of your plate can be determined by setting the depth and the width. Make sure darker is higher is selected so that the black areas of your image will be raised. Leave the colour model as linear. This means darkness will directly correspond to height. If you see the 1mm transmittance option, leave it at 50%. This setting concerns how much light gets through a layer of a lithophane, but it's not relevant to this job. Lastly, either slide or decrease the smoothing setting to 0. The smoothing setting will determine how severe the shoulder between black and white areas are. At 100%, it will create a gradual ramp, increasing in height from the base to the maximum layer height. Because we want our prints to have crisp details and sharp edges, we do not want any smoothing. Hit OK and wait for your plate to load. Next, head over to the print settings. There's heaps to get stuck into here, but for this kind of print, the Fine or MakerSpace default settings are adequate. The one thing I recommend changing is the infill. 3D printed objects are rarely generated with 100% infill, making them solid all the way through. Instead, printing at a lower infill percentage will save material and time and can be just as strong as a solid object. When you are deciding what infill to use, consider whether your object will be under any pressure and decide based on a pattern that will support the object against the direction the force is coming from. For example, our printing plates will be under force on their top face, so I'm going to choose to leave the infill on its default setting, a simple grid pattern. Because these objects are so thin and rarely have large interior spaces that require infill, I usually print them with infill as low as 20%. This makes them rigid, but still provides some flexibility so they don't snap under the pressure of the press. I also recommend leaving adhesion ticked. By ticking this, Cura will generate a brim around the base so that it can easily be removed when the print is finished. Having this brim means you can ensure that the printer is extruding the filament consistently and the bed is level before your actual matrix starts to print. If you're curious about all the other settings, hit Custom. There's plenty of changes that could be made. Hit Slice and wait for Cura to generate the instructional G code the 3D printers will read to print your plate. Once it's sliced, you can see how long it will take to print and how many grams or meters of filament you will use. If you head over to the Preview tab, you can move through the layers of the print to check out how it will come out. Name your file something you will recognize and save your file to one of the MakerSpace's SD cards by hitting Save to Removable Disk. If you made your file at home, copy it over to one of our SD cards when you get here. Next, insert your SD card into a free printer. Rotate the wheel, select Print, find your file, and hit it. The printer will start heating up, and when the nozzle is hot enough, it will melt the plastic. Once it reaches temperature, the printer will extrude some filament and then begin the brim of your print. Watch to see that the plastic is adhering nicely to the glass bed. If it is not, you can turn the screws underneath the printer as it prints, moving the bed closer or further away from the nozzle. We're looking for consistent lamination, where the plastic is sticking to the printing bed but not so close that it's spreading so thin it appears clear. Watch the first layer of your print to make sure a good foundation is being laid. There are heaps of troubleshooting resources around the MakerSpace, including links to a series of excellent, more in-depth tutorials by mentor Safi. When the first layer is complete, you can come back to the MakerSpace to collect your print whenever you like. When you return, wait for the print to cool before prying it off the bed. Discard the brim and then take it back to the studio to try printing it. In my experience, printing these plastic plates is best done by hand, but feel free to experiment.